I wish I had done implementing the neural network which would be used by the agent so that he could move and decide by himself, because currently he's moving because I'm just changing his X and Z positions. It's just using traditional computer science, computer graphics technique, but I thought I made progresses enough to make a new video, so I decided to do that. So like I mentioned, I really didn't touch on graphics side past few days, but I added some feature, which is to clamp each position, each position of the mesh so that it won't exceed these values or the boundaries. So I just set the boundaries so that each mesh won't exceed these values. So this green, so this green rectangle is a floor, and it's positioned from negative 500 to 500 on both X and Z axes, and I don't want these meshes to exceed the end of the rectangles or the side of this floor. So I don't know. I just added this clamping feature. So for the neural network, so I am implementing neural network, which is this one DQN, and which stands for Deep Q Learning. I think this is kind of beginner friendly model used when people are trying to work on reinforcement learning related AI project. So yeah, I decided to use this. So as always, I just and since I started using graphics APIs and started to make classes, because before I wasn't really using or making any classes, especially whenever I implement new AI models. But yeah, I guess I was influenced by how graphics API is used. I've started using classes for AI models as well, and yeah, so as always, I just created train and forward functions, but in fact, this train function is implemented incorrectly. Seems like this DQN I have to prepare two neural network called, one of them is called Q network and one of them is called target network. And for the Q network, I just need these dense layer or linear layers, which is just, traditional y equal wx plus b. You just pass the input and take matrix multiplication with weights and add bias and compute the activation function, and you do that you do these few times, and final value is called Q values. So up to here it's fine, but these are so, and later I have to compute things called Q-target, but this computation seems like only done in this target network. In Q network, it seems like I only need these dense layers, so I just decided to make forward function. So I'm not really sure what's gonna happen. Like, I'm not really understanding how things work yet. So, and this is the epsilon greedy, which is the policy, which just return which action to take. So I just generate random values from between 0 to 1, and if it was less than epsilon, and epsilon, all the parameters are declared in this private section of the class. So if it was less than epsilon, it seems like the AI agent would explore rather than choosing the action with the highest key value, which would be whenever these random values are greater than epsilon. So this is called policy. It's just decide which action to take. And by the way, so in reinforcement learning, the fundamental, so in reinforcement learning, you commonly have state and action. State is, in my project, in my case, the agent states, and I've decided to have 4 states, which is position position X and Z for the AI agent, the current X and Z position, and I also hunger and thirst. And the action will be just move left, right, up, and down, and maybe later I'll add rotation angle. So yeah, these are the states and actions. So this policy function would decide which action to take, from these action. And these are just weights and biases and basic parameters. So, and this is the main loop of the program, and I initialized so first I drew meshes, I rendered everything, and I retrieve agents X and Z position after first time rendered, and randomly set the hunger and the thirst. Normally, people use in the beginning of the loop, they would use reset function from the environment class. So I have implemented the environment class, which would generate, so typically, whenever you're training reinforcement learning, sometimes, so you could decide went to finish the training, whenever, for instance, whenever agent gained enough rewards, then you could stop the training. Or maybe agent got killed by some monster. That's another threshold to stop the training. And whenever you restart the training, normally you'd call this reset function on environment class, which would generate new states, which would be, for my case, X and Z position and hunger. But I haven't really I haven't, for now it's pretty hard for me to decide how to integrate this reset function, because I first rendered the agent, which would have position X and Z already, and it doesn't make sense to call this function to generate position X and Z, because the meshes are, or the agent is already rendered, which has some position. So this is the thing I really have to decide what to do. So this is the environment. These are the functions in environment function, and I'm not really sure how to use this, but maybe this is when not training. This is used by during the training, when the training is still on. This is so this function return the current states and also the reward. So the main purpose of this training, or the reinforcement learning, is to gain this reward as much as possible. For my AI project now, he would gain this reward whenever he get close to the water cubes and food cube. So he would get reward whenever he get close to these meshes, and actually when he collided with these meshes, which means he has drunk water and he has eaten food. So I'm not really sure how to decide whether he has eaten food or get hydrated yet. So so this is the step function, and this is pretty much it. And I maybe use multi-threading to simultaneously render these meshes, but on the other side I do the training, because after I introduced this train function, this one, my FP frame per second has lost and has decreased. It's pretty much, rendering quality of rendering has decreased. So maybe I have to use multi-threading later, but first I have to uh, decide how to integrate these. And also I haven't done implementing the back propagation. So after I've done uh, after I've done writing all the code, including back propagation, maybe I'll introduce multi-threading. But yeah, I think this is this is how things gonna work for now. And I also added timer class to calculate the delta time, which would be used to smoothly render the meshes. And I also added the AI and CUDA folder because I don't really want to mix these AI related files with graphics related files. And I also have files only for kernels. Maybe I would unify all these functions, because maybe this is kind of absurd to separate each functions into each files. I guess this is too much. And also, this is pretty big thing, but so whenever you're working on AI, you'd use different kinds of functions, like you'd use this function Robert uniform to initialize the weights, and zeros to initialize biases, and also of course transpose and matrix multiplication and so on. I just realized these are all operations, so I decided to put all these functions in file called ops because it's pretty neat. Before, I used to had multiple files for these functions, but in fact you don't really use that much functions. I mean, I have more functions here, and these are also just operations. And I used to have files that only include mapmo and transpose. Like, these are all used during training, a train function. So, and in TensorFlow or in PyTorch, they create a graph, and in that graph, all these operations are included. So they consider these functions as just operations, and it's just neat in this way. So I did that. Yeah, I think this is it for today. And also, this is how it looks like on console. It's actually training, I mean, this word function, but it's pretty messed up currently. Yeah. So Yeah, I think this is it for today's video, and I think by the next video I would be done implementing the neural network, I hope, so that I could show you guys the AI agent moving by himself rather than me changing his position. Yeah, so thanks for sticking to the end of the video, and as always, thanks for all the supports. Yeah, thanks.